In 1947, inside a machine shop in Ypsilanti, Michigan, an American automotive dream was quietly dying. Preston Tucker's revolutionary prototype car, the Tin Goose, had a fatal flaw. Its massive 589 cubic inch engine was a mechanical disaster, too loud, horribly underpowered, and built without a reverse gear. Desperate to save the company, chief mechanic Eddie Offutt looked away from Detroit and toward the sky. He secretly brought in a 335 cubic inch flat six engine built by air-cooled motors, a power plant originally designed for a Bell helicopter. It weighed less than 320 pounds but produced 166 horsepower and a staggering 372 pound-feet of torque. In a frantic few weeks, Offutt's team did the impossible. They successfully converted the air-cooled aviation block into a water-cooled automotive engine. To guarantee the supply line, Tucker did something reckless. He bought the entire Franklin Aviation Engine Company for $1.8 million. The paradox was absolute. The engine ran flawlessly, but the financial system required to build it was already collapsing. But the real story of the Tucker O-335 is not only the story of a desperate 1947 engine swap. It is the story of an aviation masterpiece trapped in the ruthless reality of American automotive economics. Every week, we tell the stories of American engines, factories, machines, and industrial names that once taught the country what power sounded like and what happened when the market moved on. Subscribe if that history matters to you. The story begins not with nostalgia, but with a specific place, in Syracuse, New York, in 1945. In the immediate aftermath of the Second World War, the American automotive landscape was defined by a strange, uninspired quiet. Millions of soldiers had returned home to an economy flush with cash and a desperate hunger for the future. But when they walked into dealerships in Detroit, Chicago, or Los Angeles in 1946, the future was nowhere to be found. The big three automakers, General Motors, Ford, and Chrysler, were entirely focused on meeting massive pent-up demand. They did not need to innovate to sell cars. Instead, they dusted off their pre-war 1941 blueprints, added slightly different chrome trim, and pushed them onto the showroom floors. Beneath the hoods of these cars sat the unquestioned standard of American power: heavy, cast-iron inline sixes and flathead V8s. These engines were durable, heavy, and fundamentally rooted in the engineering of the 1930s. They were bolted to heavy steel frames, driving the rear wheels through long, heavy drive shafts. In an American garage of 1946, an engine was a massive block of iron that made relatively low horsepower for its immense weight. Preston Tucker, a former car salesman and industrial entrepreneur, saw this complacency as a vulnerability. He promised the American public the car of tomorrow, the Tucker 48. It would have aerodynamic styling, a center headlight that turned with the steering wheel, a padded dashboard for safety, and most radically, an engine mounted in the rear. But a revolutionary car is only a drawing until it has a beating heart. Tucker needed a power plant that could back up his futuristic claims. The initial answer was a colossal engineering gamble: the Tucker 589. Designed specifically for the car, the 589 was a massive flat-six engine. Displacement, the total volume swept by the pistons inside the cylinders, measured a staggering 589 cubic inches, or nearly 9.6 liters. To put that into perspective, most standard American car engines of the era displaced around 200 to 240 cubic inches. The 589 was designed to idle at an impossibly low 100 RPM and cruise at highway speeds while barely breaking a sweat. It featured an eccentric design using oil pressure to operate the valves instead of a traditional mechanical camshaft, the shaft that typically controls valve opening and closing. But the 589 was an unmitigated disaster. When Tucker debuted his first prototype, affectionately called the Tin Goose, in Chicago in June 1947, the 589 engine was practically tearing itself apart. The oil pressure valve system could not maintain adequate pressure, making the engine incredibly difficult to start. When it did run, it was deafeningly loud. During the highly publicized reveal, Tucker instructed the brass band to play as loudly as possible just to drown out the violent mechanical clatter of his own engine. Worse still, the transmission it was mated to did not even have a reverse gear. The 589 was too heavy, too loud, and entirely non-functional for a production automobile. Tucker's engineers, led by Chief Mechanic Eddie Offutt, realized that if they tried to fix the 589, the company would bleed to death before a single car ever reached a customer. They needed a new engine, and they needed it in a matter of weeks. They could not buy engines from Detroit. The Big Three viewed Tucker as a threat and had no interest in supplying him. So Offutt and Tucker looked away from the American highway and turned their attention to the sky. In Syracuse, New York, a company called Air-Cooled Motors was quietly building some of the most reliable aviation engines in the world. The company was the descendant of the H. Franklin Manufacturing Company, an early American automaker that had pioneered air-cooled engine technology in the 1920s and 30s. By 1947, Air-Cooled Motors was producing power plants for light aircraft, including a specific model designated for the Bell 47 helicopter, the Franklin O-335. The O-335 was a radical departure from anything sitting in a Detroit showroom. It was a flat six engine, a design where six cylinders are arranged in two horizontal banks opposing each other, laying flat like a pancake. This layout naturally balanced internal vibrations and drastically lowered the engine's center of gravity. More importantly, it featured an aluminum block. The block, the main engine structure that holds the cylinders and major internal parts, was cast from aluminum instead of heavy cast iron. This meant the O-335 weighed barely over 300 pounds. Despite its light weight, its 335 cubic inches of displacement produced 166 horsepower and a massive 372 pound-feet of torque. Torque is the twisting force of an engine, the brute pulling strength a driver feels pressing them back into the seat when accelerating. To understand how staggering these numbers were, consider that a standard 1947 Ford Flathead V8 produced about 100 horsepower and weighed hundreds of pounds more. The Franklin O-335 was light, incredibly strong, and built to the exacting zero-failure tolerances of the aviation industry. But there was a severe structural problem. The O in O-335 stood for opposed, and the engine was entirely air-cooled. An air-cooled engine relies on metal fins cast into the cylinders and high-speed airflow to dissipate heat, entirely skipping the heavy liquid coolant, water pump, and radiator used in most cars. In an airplane or a helicopter, air cooling works perfectly. The engine is constantly fed a stream of high-velocity, freezing air at altitude, but Tucker intended to take this aviation engine and bury it inside the enclosed rear sheet metal of a heavy steel automobile. A helicopter engine is designed for sustained, continuous RPMs in the open air. It is not designed to sit idling at a red light in Chicago in August. It is not designed for the stop-and-go realities of an American traffic jam. If they dropped the air-cooled O-335 directly into the Tucker 48, it would violently overheat and destroy itself within miles. The engine was a proven masterpiece in the air, but America's highways required a completely different kind of survival. Inside the Ypsilanti machine shop in the fall of 1947, Chief Mechanic Eddie Offutt and his team were fighting a war against time and thermodynamics. They had a brilliant aviation engine sitting on the floor, the Franklin O-335, but in its current state, it was entirely useless for an American automobile. The engine was air-cooled, relying on the freezing, high-velocity airflow of a helicopter in flight to keep its metal from melting. If they placed it inside the enclosed rear engine bay of the Tucker 48, it would suffocate and destroy itself in minutes on a hot highway. They had to convert the O-335 to a liquid-cooled engine, a system that pumps a mixture of water and coolant through internal passages to absorb heat before cycling it out to a radiator. This was not a simple modification. An engine block, the main metal structure that holds the cylinders and internal moving parts, is usually cast at a foundry with these liquid passages, known as water jackets, already designed inside the metal. The Franklin aviation block had no water jackets. It only had external cooling fins. In a frantic display of American garage ingenuity, Offutt's team stripped the cooling fins off the Franklin's 6 individual cylinders. They then fabricated custom brass and aluminum water jackets, sliding them over the bare cylinders and welding them perfectly watertight. They devised a system of heavy rubber hoses and metal plumbing to carry the hot coolant all the way from the rear-mounted engine to a massive radiator, a heat exchanger designed to catch the oncoming wind, mounted at the very front of the car. The machine shop essentially had to re-engineer an aviation power plant into an automotive one by hand, cylinder by cylinder. But when they finally bolted the modified O-335 to an engine stand, filled it with water, and fired it up, the results shocked everyone in the room. The converted Franklin engine was a mechanical revelation. Because it retained its aluminum block, a block poured from lightweight aluminum rather than heavy cast iron, the entire engine weighed just 320 pounds. Yet from its 335 cubic inches of displacement, it produced a verified 166 horsepower and a massive 372 pound-feet of torque. To understand the magnitude of this breakthrough, one must look at what Detroit was offering at the exact same moment. A 1947 Ford Flathead V8, the darling of the American highway and the emerging hot rod culture, weighed over 500 pounds and produced just 100 horsepower. General Motors and Chrysler were building cast-iron inline engines that were equally heavy and sluggish. The Big Three were building engines for a pre-war world. Tucker's team had just built a lightweight, high-torque, aluminum flat six that belonged in the next decade. The flat six layout, where the cylinders lay horizontally opposite each other, provided a massive advantage for the Tucker 48. It allowed the engine to sit incredibly low in the rear of the chassis. This eliminated the need for a bulky drive shaft tunnel running down the center of the car, giving the Tucker a completely flat interior floor. It also kept the car's center of gravity close to the pavement, offering handling characteristics that tall, front-heavy Detroit sedans simply could not match. But a prototype engine on a stand in a Michigan machine shop is not a production reality. Tucker had to prove that this modified helicopter engine could survive the brutal, unforgiving reality of the American driver. In aviation, engines are meticulously maintained, rebuilt at strict intervals, and operated by trained pilots who monitor every gauge. On the American highway, engines are neglected. They are pushed hard up mountain grades, idled for hours in freezing Midwestern winters, and subjected to low-quality gasoline. If the O-335 was going to power the car of tomorrow, it had to prove it possessed absolute mechanical durability. The engineering team set up a brutal validation test. They bolted the newly water-cooled O-335 to a dynamometer, a machine that measures engine power and load, and opened the throttle wide open. They left it there for 150 continuous hours. For more than 6 days and nights, the aluminum flat six screamed at maximum output. In a standard automotive engine of 1947, running at full throttle for 150 hours would likely melt a piston or snap a connecting rod, the critical metal arm that links the piston to the spinning crankshaft. The heat would warp the cylinder heads. The oil would break down. The block would fail, but the O-335 did not fail. Because it was originally engineered to aviation standards, where a snapped connecting rod means a helicopter falls out of the sky, the internal components were forged from high-grade steel and machined to zero-tolerance perfection. When the 150-hour test finally ended, the equivalent of driving 18,000 miles at 100 miles per hour without ever lifting off the gas pedal, the engine was torn down and inspected. The bearings were pristine. The block was perfectly straight. The water cooling modification had held up flawlessly. Preston Tucker finally had his power plant. It was lightweight, immensely powerful, incredibly smooth, and practically indestructible. But there was a new massive problem. Air-cooled Motors in Syracuse was not an automotive supplier. They were an aviation company owned by Republic Aviation. Tucker could not simply order a few thousand engines and hope they arrived on time. If Republic Aviation decided to cancel his contract, or if the military suddenly needed more helicopter engines, the Tucker 48 assembly line would instantly die. To build an American car company, you had to control your own castings, your own machining lines, and your own foundries. In a move of staggering financial audacity, Preston Tucker gathered $1.8 million of his investors' capital and bought air-cooled motors outright. He didn't just buy a contract, he bought the entire Syracuse factory, the workforce, the tooling, and the patents. He renamed the division the Tucker Aircraft Corporation and canceled all of the company's aviation contracts except for the ones strictly required by the military. Every ounce of manufacturing energy in the Syracuse plant was immediately redirected away from the sky and toward the Tucker 48. For a brief, shining moment in early 1948, the pieces of a new American engine empire were perfectly aligned. The engineering was verified. The Syracuse engine plant was producing the blocks. And in Chicago, the massive Dodge assembly plant, a sprawling wartime factory leased by Tucker, was preparing to drop these aluminum masterpieces into the rear of the most advanced cars the country had ever seen. The machine shop had solved the physics, but the factory floor now had to solve the economics. To understand the sheer ambition of what Preston Tucker was attempting in the spring of 1948, one has to look at the physical scale of the operation. He did not just rent a small warehouse to assemble a few boutique sports cars. He leased the Dodge Chicago plant, a sprawling 477-acre industrial behemoth that had been built by the government during the Second World War. Just a few years earlier, this exact factory floor had been used to machine and assemble massive Wright Cyclone radial engines for B-29 bombers. Now, Tucker intended to use it to break the Detroit monopoly. The arrival of the first production-ready Franklin O-335 engines from the Syracuse plant marked a profound shift. The project was no longer a frantic experiment in a Michigan machine shop. It was becoming a physical, moving assembly line. Inside the cavernous halls of the Chicago plant, workers began to marry the heavy steel frames of the Tucker 48 to the lightweight, water-cooled aviation engines. The contrast was striking. American auto workers were accustomed to dropping massive, dark cast-iron blocks into the front engine bays of sedans. Now they were taking a gleaming, 320-pound aluminum flat-six and bolting it behind the rear axle. Because the O-335 was so compact and lay entirely flat, it sat below the sightline of the rear window. A mechanic could access the entire power plant simply by opening a rear hatch, exposing a beautifully laid-out piece of machinery that looked more like an aircraft component than a standard car motor. In an America where an engine could decide whether a field was cut, a truck made its delivery, a boat left the dock, a generator carried a hospital through a storm, or a plane lifted from the runway, power was not an abstraction. It was iron, fuel, labor, heat, sound, repair, and trust. For decades, the Big Three in Detroit had held a monopoly on that trust for the American driver. General Motors, Ford, and Chrysler dictated what a car sounded like, how much fuel it burned, and how heavy it had to be. If an independent automaker wanted to survive, they usually had to buy engines from a larger supplier, forever remaining at the mercy of another company's production schedule and pricing. But Tucker had bypassed the system entirely. By purchasing air-cooled motors for $1.8 million, he owned the foundry, the casting molds, the machining lines, and the patents. He had an engine that Detroit could not control, could not throttle, and could not easily replicate without spending millions of dollars on new aluminum casting facilities. When the first pilot models of the Tucker 48 were finally assembled and driven out onto the factory's private test track, the O-335 proved that the 150-hour dyno test had not been a fluke. The cars were extraordinarily fast for 1948, pushed by 166 horsepower and that massive 372 pound-feet of torque. The heavy sedans could accelerate from 0 to 60 miles per hour in just 10 seconds, and they could comfortably cruise at 100 miles per hour. The flat-six engine ran with a smooth sewing machine precision. Because it was mounted in the rear, pushing the car forward rather than pulling it, the cabin was astonishingly quiet. The sound of the Tucker 48 was not the deep, rumbling clatter of a Detroit flathead V8. It was a tight, synchronized mechanical hum, the sound of zero-tolerance aviation engineering adapted for the highway. For the mechanics and engineers walking the floor of the Dodge Chicago plant, the engine represented more than just a clever technical solution. It was physical proof that the system could be beaten. They had taken a helicopter engine, torn off its cooling fins, welded on water jackets, dropped it into a family sedan, and created a machine that outperformed almost everything the established automotive empire was currently building. The engines were no longer just surviving on a test stand. They were rolling off the line, idling smoothly at the end of the factory floor, ready to be shipped out to a newly established network of independent dealers who believed they were about to sell the future. By the summer of 1948, the Chicago Dodge plant was no longer just an empty cavern of wartime memory. It was an active, moving assembly line. Despite mounting skepticism in the national press, 51 pilot models of the Tucker 48 were being assembled by hand. And at the heart of this impossible industrial push was the Franklin O-335 engine. Mechanics who had spent their entire careers tuning heavy, front-mounted cast-iron inline engines were now learning the precise, exacting rhythms of a rear-mounted aluminum aviation flat six. To stand behind a running Tucker 48 in 1948 was a strange and completely foreign experience for an American driver. There was no heavy vibration shaking the steering column. There was no massive radiator fan roaring from the front grille. Because the engine was perfectly balanced horizontally and insulated in the rear compartment, it idled with an eerie sewing machine quiet. Yet when a test driver pressed the accelerator, the engine immediately revealed its helicopter DNA. The throttle response was instant. The engine fed fuel into the 6 aluminum cylinders, and the heavy sedan lunged forward with 372 pound-feet of torque. It possessed a power-to-weight ratio that American family cars simply did not have in the late 1940s. It was the mechanical equivalent of placing a lightweight sports car engine into a massive highway cruiser without sacrificing an ounce of durability. Tucker sent these pilot cars on a nationwide dealership tour to prove to the American public that the machine was real. Across the country, from small-town showrooms to massive city auto shows, crowds gathered just to look at the rear engine bay. They marveled at the bizarre but beautiful engineering, the water-cooled jackets meticulously welded onto the helicopter cylinders, the compact block, the gleaming aluminum that looked entirely out of place in an era of dark, oil-stained cast iron. The O-335 proved something dangerous. It proved that a startup automotive company did not have to settle for buying underpowered, outdated iron from a larger supplier. By purchasing the air-cooled motors factory in Syracuse, Preston Tucker had secured his own supply line, his own foundry, and the most mechanically advanced automotive power plant of the decade. For a fleeting, incredible moment, it looked as though the American engine empire was actually about to fracture. The big three automakers in Detroit were watching a massive, government-built factory in Chicago pump out a vehicle that made their own 1948 models look entirely obsolete. The engine had passed the brutal 150-hour dynamometer tests. The supply chain from New York was secured. The foundries were actively pouring aluminum. The assembly line was moving, and the iron was finally out on the road. The engineers and machinists had done their jobs perfectly. They had built a machine that could theoretically run forever. The engine was ready to rewrite American highways, but the industry it threatened was already moving to shut the factory doors. The first crack in the Tucker engine empire did not happen on a test track, and it did not come from a broken piston, a cracked block, or a failed water jacket. It began quietly in Washington, D.C. in the spring of 1948 with a letter from the Securities and Exchange Commission. The SEC had begun quietly asking questions about how Preston Tucker was funding his massive operation. Building a new automobile from scratch is incredibly expensive, but building an entirely new American engine supply chain, buying the air-cooled motors factory for $1.8 million, securing aluminum foundries, retaining aircraft-grade machinists in Syracuse, and running the colossal Chicago Dodge assembly plant required an ocean of constant capital. Because the big three automakers and traditional Detroit banks refused to support him, Tucker had resorted to unorthodox fundraising. He sold dealership rights before the car was even finished. He launched an accessory program, allowing eager customers to buy customized radios, seat covers, and custom luggage to guarantee their spot on the waiting list. To the engineers on the factory floor, these were just necessary financial maneuvers to keep the engine line moving. To federal regulators, it looked like a company selling promises instead of hardware. The pressure remained behind closed doors until the evening of June 13, 1948. On that night, highly influential radio broadcaster Drew Pearson told his national audience that the SEC was preparing a massive investigation into the Tucker Corporation, implying that the entire company was a massive fraud and the car was a fake. The market reaction was instantaneous and devastating. Overnight, the stock price plummeted. Dealerships that were preparing to order more cars suddenly panicked and froze their accounts. The steady stream of cash that had been fueling the machine shops, the foundries, and the assembly line was violently severed. This is where the brutal reality of Force One, iron, aluminum, fuel, and manufacturing costs, took hold. The Franklin O-335 was a brilliant piece of engineering, but it was not cheap to build. Pouring an aluminum block, the main engine structure, requires precise temperature control and specialized casting molds. Welding custom liquid cooling jackets onto helicopter cylinders requires highly skilled, highly paid labor. Maintaining a workforce of aviation mechanics in Syracuse, New York, while simultaneously paying thousands of assembly line workers in Chicago, meant the company burned through thousands of dollars a day just to keep the lights on. Without new capital coming in from dealers and investors, the entire supply chain began to seize. By the late summer of 1948, the bustling floor of the Chicago Dodge plant started to grow quiet. The shipments of gleaming aluminum, flat-six engines from air-cooled motors began to slow down, and then they stopped entirely. Workers who had just learned the precise, unfamiliar rhythm of dropping a rear-mounted aviation engine into an American family sedan were abruptly sent home. The silence inside the massive 477-acre facility was deafening. Just months earlier, this building was supposed to represent the end of Detroit's monopoly on American power. Now 51 pilot cars sat inside the cavernous halls, their 166 horsepower, water-cooled engines completely assembled, perfectly timed and ready to drive. But there was no money left to build the 52nd car. The government descended on the factory. Federal agents confiscated filing cabinets, engineering blueprints, and financial records. They walked past the gleaming Tucker 48s, largely ignoring the mechanical miracle sitting under the rear hoods. The investigators were looking for a scam. They assumed that because Preston Tucker was running out of money, his engineers must have been faking the technology. But the tragedy of the Tucker O-335 was that the engineering was entirely real. The engine did not overheat. The block did not crack. The heavily modified helicopter cylinders held their water flawlessly. The mechanics in Ypsilanti and the assembly workers in Chicago had done exactly what they promised. They had built a lightweight, incredibly powerful, horizontally opposed aluminum engine decades before Porsche would make that exact layout famous on American roads. The iron was solid. The business model around it was collapsing. Tucker and his executives were indicted on federal charges of mail fraud and conspiracy. The factory was locked down. The Syracuse engine plant, which had just transitioned its entire identity toward revolutionizing the American highway, was thrown into a state of corporate paralysis. The automotive dream was over, and the battle for survival had moved to a federal courtroom. The engine had not failed a single mechanical test, but it was about to be put on trial for a crime it did not commit. By the winter of 1949, the immense Dodge Chicago plant was completely locked down. The sprawling 477-acre facility, which just months earlier had been alive with the sound of pneumatic tools and aluminum machining, was now a silent tomb for an aborted American engine empire. Inside, 51 completed Tucker 48s sat parked in neat rows. Scattered across the factory floor were wooden pallets loaded with brand-new, water-cooled Franklin O-335 engines, gleaming aluminum flat sixes that had been fully assembled in Syracuse, shipped to Chicago, and were now waiting for car frames that would never be built. The battle for the engine's survival moved from the machine shop to the federal courthouse. During the highly publicized fraud trial, government prosecutors attempted to prove that Preston Tucker had never intended to build a functioning automobile. They pointed to the early failure of the massive 589 cubic inch engine and argued that the car was a mechanical hoax. They claimed it could not reverse, it could not idle, and it could not be mass-produced. But the prosecutors had fundamentally misunderstood what had happened in that Ypsilanti machine shop. They were arguing against the ghost of the old 589. They were entirely unprepared for the reality of the Franklin O-335. To defend the company, Chief Mechanic Eddie Offutt and his engineering team took the stand. They did not use financial projections to argue their case. They used physical iron. They submitted the engineering logs from the brutal 150-hour dynamometer test. They brought the cars to the courthouse. They proved that the heavily modified helicopter engine did not overheat in traffic, that it produced a verified 166 horsepower, and that the transmission bolted to it functioned perfectly. The defense argued that you do not buy an entire aviation engine factory for $1.8 million, convert its assembly lines, and cast hundreds of new aluminum blocks if you are only running a paper scam. The jury listened to the mechanics. They looked at the cars, and on January 22, 1950, Preston Tucker and his executives were acquitted of all charges. The federal court formally declared that the engineering was real, the effort was genuine, and no fraud had been committed. But the verdict did not matter. The trial had lasted long enough to achieve what the big three automakers had hoped for. It bled the Tucker Corporation completely dry. This was the ultimate trap of Force 6, corporate consolidation and financial collapse. An engine company can survive a bad casting, a blown head gasket, or a flawed fuel system. It cannot survive the total evaporation of its operating capital. The Tucker Corporation was forced into bankruptcy. All assets were seized by receivers and prepared for public auction. The tragedy of the O-335 was fully realized on the auction block. The 51 completed cars, the spare parts, and the unassembled aluminum engines were sold off for pennies on the dollar to collectors, former dealers, and curious mechanics. The tooling in the Chicago plant was dismantled. The workers who had trained to build the rear-mounted flat six were permanently dismissed, forced to look for jobs in traditional foundries, pouring heavy cast iron blocks for Ford, General Motors, and Chrysler. The most devastating blow fell on Syracuse, New York. Air-cooled Motors, the aviation company that had cast its lot with the American automotive future, was dragged into the Tucker bankruptcy. Because Preston Tucker had purchased the company outright, the Syracuse factory was now considered an asset of the dead automotive corporation. Its ownership was frozen in a massive legal entanglement. For years, the factory that had built the magnificent O-335 languished in financial limbo. It eventually reverted to building standard air-cooled helicopter engines, but the capital drain of the Tucker collapse had permanently damaged its momentum. Decades later, after passing through various corporate hands, the remnants of the Franklin engine empire were sold off to PZL, a Polish state-owned aviation manufacturer. The American company that had once built the most advanced automotive engine in the country ended up as a foreign aerospace asset. Back in Detroit, the Big Three took a deep breath and went back to business as usual. They ignored the lessons of the lightweight aluminum block. They ignored the packaging advantages of the flat six layout. In the early 1950s, Ford and Chevrolet introduced their new overhead valve V8 engines, heavy, front-mounted, liquid-cooled, cast iron blocks that would go on to define American hot rodding, highway cruising, and automotive culture for the next 40 years. The aluminum revolution was delayed. It would take decades before foreign companies like Porsche and Subaru would teach the American public to trust a horizontally opposed flat six, and even longer before aluminum blocks became an industry standard. Tucker's team had built the right engine at the right time, but they had tried to feed it into a financial system that refused to let it live. The Ypsilanti machine shop was emptied. The 150-hour test logs were filed away. The aluminum blocks were sold at auction. The Chicago assembly line was dead. The engine still ran. The funding stopped. The factory locked. The workforce left. The badge remained. The world it was built to power was gone. The Tucker Corporation was liquidated, but the engine it tried to bring to the American highway did not immediately die. Air-cooled Motors, the Syracuse-based manufacturer that Preston Tucker had purchased for $1.8 million, was caught in the legal wreckage of the bankruptcy. Because it was officially a Tucker asset, the federal government placed the engine factory into a trust, holding it in a prolonged state of financial paralysis. It took years for the facility to be fully disentangled from the automotive disaster. When it finally emerged, air-cooled Motors abandoned the highway entirely. They stripped the custom water jackets off their aluminum blocks, reinstalled the cooling fins, and went back to the only thing that made financial sense: building air-cooled engines for helicopters and light aircraft. But the momentum was gone. The immense capital drain of the Tucker experiment had permanently wounded the company. After passing through a series of corporate owners, the Franklin engine designs and the manufacturing rights were eventually sold in 1975 to PZL, a Polish state-owned aviation manufacturer. The brilliant American aviation company that had briefly threatened Detroit's cast iron monopoly was shipped overseas, becoming a foreign aerospace asset. Today, the sprawling Chicago Dodge plant, where the water-cooled flat-six engines were supposed to revolutionize the American road, no longer builds automobiles. A massive portion of that historic 477-acre industrial site was eventually redeveloped into the Ford City Mall, a sprawling commercial shopping center built quite literally over the footprint of a failed automotive revolution. The Ypsilanti machine shop, where chief mechanic Eddie Offutt first figured out how to convert the helicopter engine, has faded into the background of Michigan's manufacturing memory. But the iron itself refused to disappear. Of the 51 original Tucker 48s built before the factory doors were padlocked, an astonishing 47 still survive today. They are kept in climate-controlled museums, like the Henry Ford Museum in Dearborn, the Peterson Automotive Museum in Los Angeles, and in highly guarded private collections. These surviving engines are heavily isolated by Force 8, the reality of industrial afterlife and working relics. Keeping a Tucker O-335 running today is a monumental challenge. You cannot walk into a modern auto parts store and order a water pump or a head gasket for a 1948 Tucker. Because the engine was originally a Franklin aviation power plant, mechanics tasked with restoring a Tucker 48 must often hunt down vintage helicopter parts or custom machine components from scratch. The engine requires specialized knowledge that straddles the line between classic car restoration and vintage aircraft maintenance. But this preservation is not just nostalgia for a beautiful car. It is a physical, undeniable defense of the engineering itself. When a restorer today opens the heavy rear hatch of a surviving Tucker 48 and turns the ignition, they are not just starting a classic car. They are providing a legal and mechanical argument. The engine still fires up. The aluminum block still holds compression. The custom welded water jackets do not leak. The engine still produces that immense 372 pound-feet of torque, and it still idles with a quiet, sewing machine precision that no cast-iron Detroit V8 of the era could ever replicate. Every time one of those 47 engines turns over, it proves that the prosecutors, the skeptical press, and the federal investigators were wrong. The Tucker 48 was never a hoax. The car of tomorrow was entirely real, and the power plant that drove it was a legitimate masterpiece. Preston Tucker and his team had correctly predicted the future. They had recognized the packaging advantages of a flat-six engine. They had understood the weight savings of an aluminum block. They had brought aviation-grade tolerances to the American highway decades before European imports would convince the American public that a rear-mounted air-cooled or water-cooled flat-six was the ultimate sports car layout. The machine shop had solved the physics. The engineers had successfully bridged the gap between the sky and the street. But they could not solve the brutal, unyielding reality of American automotive economics. Force 1, the massive cost of manufacturing, casting, and capital. And Force 6, corporate consolidation, destroyed the company before the engine ever had a chance to prove itself to the American driver. The Tucker O-335 teaches a harsh lesson about American industrial power. An engine can be mechanically perfect, incredibly powerful, and decades ahead of its time. But if the financial system around it collapses, the factory line will still go dark. Somewhere in America today, parked on the manicured grass of an exclusive classic car show, a Tucker 48 sits with its rear engine lid raised. The afternoon sun catches the gleaming aluminum of the modified helicopter block. A mechanic turns the key, the starter engages, and the flat-six fires to life, settling into a smooth, quiet idle. The sound of an American future that was built, paid for, and then locked away in the past. See you in the next one.